Whether you're a large corporation looking to store your big data, a mom and pop business looking to store its sales invoices and receipts, or you're just looking for a place to keep those 7 zettabytes of selfies you've been accumulating.
7 zettabytes?
Most of it was Jeff's.
Maybe cloud storage is just a bit too ethereal for your liking, or maybe an external hard drive just isn't quite as redundant as you would like, or maybe you just need a huge amount of storage. In these cases, a dedicated storage appliance is probably going to be a necessity. But what is storage? Who is storage? Why is storage? Well, if these questions ever vex you from time to time, then you've come to the right place. Go ahead and start your tape recorders and make sure those number 2 pencils are sharp, because this is Brainmelt University and class is in session. First things first, when we're talking about storage, we're talking about memory, but specifically, we're talking about memory that is non-volatile. Or in layman's terms, that's memory that does not go away if the device loses power. While some manufacturers and vendors tend to use the terms memory and storage interchangeably, that's not actually going to be the case most of the time. Some forms of memory are volatile, such as in the case of random access memory or RAM. This is memory that goes away if your device powers down for any reason, whether it's planned or unplanned. So just keep in mind, for the purpose of this discussion, we're going to be referring specifically to non-volatile memory. When it comes to storage nowadays, we typically accomplish storage through one of 2 forms of storage media, either an HDD, a hard disk drive, or a solid-state drive, SSD. HDDs are pretty ancient technology by tech standards, having been around since the 1950s. However, they are still a currently used technology and they are still being manufactured today. An HDD's main advantage over an SSD is that they're going to be cheaper when you're dealing with larger capacity drives like the ones that would be used in a network attached storage appliance. Hold on, we're not there yet. However, as a trade-off, their read and write speeds are pretty slow, and they tend to fluctuate depending on the rotations per minute that the disk inside that drive spins. For instance, in theory, a 10,800 RPM hard drive would have twice the read-write speed of a 5,400 RPM hard drive, both of which are still manufactured and sold today. This is of course dependent on bus speeds. Just because you can read or write data to that disk doesn't necessarily mean that that data can reach the disk at the same speed. We'll talk about bus in a second. Just so we're all on the same page, the bus is the internal connections inside your computer or computing device. SSDs are the newer way of doing things, and their price has come way down in the past decade. However, when we're talking about larger capacity drives, they're still quite a bit more expensive than their HDD counterpart. The main advantages of an SSD are that they have no moving parts. They're not a mechanical device like with an HDD, so there's a lot less chance of a mechanical failure. Basically, there's no chance of a mechanical failure. It's all electronic. In addition to that, their read and write speeds are incredibly fast in comparison to just about any hard drive, regardless of its rotations per minute of the disk inside. However, SSDs do have one major limitation, and that is that you can only read and write to a specific section of an SSD a finite number of times before it becomes inoperable. So eventually that SSD is going to fail just like an HDD. For home users, SSDs tend to outlive their HDD counterparts because of these basic advantages that it has, and the number of read and writes that you can do to an SSD are quite high for your average home user. HDDs tend to wear out faster if the motor inside has to constantly come to a stop and start again, such as in the case of rebooting your computer. Also, if you tilt a HDD while it's in operation, for instance, if you're using a laptop as a laptop, then that's also going to create unnecessary stress on the internal motor of the drive and reduce its service life, which is one reason why laptop hard drives tend to wear out at a much faster rate than desktop hard drives. However, when we're talking about a dedicated storage device, something that just sits on a desk or in an equipment rack somewhere and is always powered on and is constantly trying to optimize and shift the data around to make it easier and faster to access, then the difference in service life between SSDs and HDDs becomes much less pronounced, as SSDs are going to constantly have data being written and removed, and your HDDs are no longer being subjected to the same stress that they might receive if they were mounted in, say, a laptop. There are also hybrid drives which store their data on a traditional spinning hard disk, but also have an SSD chipset used for caching commonly used files. Basically, the intent was to give you the best of both worlds. However, this technology never really took off because traditional hard drives and SSDs both existed at the same time. Intel Optane was another technology that kind of functioned on the same principle. This was an additional chipset that you could add to your computer that would basically start caching commonly used files, so that the Optane chipset ended up serving as an SSD cache for your internal traditional hard drive. Both hybrid drives and Optane are kind of technological dead ends, but certification bodies still love throwing these on cert exams, which is one reason why I bring them up here. Just in case you are studying for certification exams while watching this video, there are a few other outdated forms of centralized backups, such as CD and DVD arrays, tape drives, and flash drives. All of these are outdated and are not used anymore. However, there are still tons of organizations out there that still have backups on these old forms of media, and it doesn't matter how high-tech your current storage solution is, there are still tons of organizations out there that just have a shelf somewhere packed full of storage tapes. Centralized on-site storage is usually accomplished by one of three methods. The first is through a dedicated file server. This is a dedicated server somewhere that has been configured to allow external users through your network to access specific drives within that server's chassis. This is an older way of doing things because server blades are actually quite expensive. You end up with quite a few wasted resources just by serving as a file server, and especially with one-use server blades, these tend to have a small form factor restriction. You can only use the 2.5-inch drives with these server blades. This is usually, but not always, the case. People have been moving away from this method for this reason, but if you do have a server blade just sitting around collecting dust somewhere, this does give you an option to actually put that server to good use by using it for centralized storage. You may also have some additional software costs over some other form of storage because the operating system on your server may need to be upgraded at some point in order to keep receiving the necessary security updates. Even if you were to go with a Linux operating system for this server, it doesn't necessarily mean that it's going to be completely cost-free when it comes to the software that is running on that server. Also, servers don't tend to have the highest quality or highest speed NICs available, meaning that no matter how fast the buses are inside your device, no matter how many CPU cores or how much RAM it has, you're still going to be bottlenecked by that fast Ethernet NIC sitting on that old-ass file server. The next and most common method of implementing some sort of centralized storage on your network is to utilize a network-attached storage appliance, or NAS for short. NAS are purpose-built boxes that contain just enough of an operating system and additional resources necessary to manage the disks that are installed on them. These can be configured with different RAID levels, different volumes, different security permissions, etc. The amount of storage that a NAS is capable of providing is dependent on your RAID configuration, the number of drive bays it has available, and the capacity of each hard drive installed in each of those bays. Some basic considerations to consider when you are selecting a NAS appliance are the number of drive bays available, any applicable capacity limits per disk, the speed and number of network interfaces, and the internal bus and socket types. There are three main types of drive sockets used in NAS appliances. The first and least common of these is the M2 SATA socket. These are rarely used except as cache drives in order to improve the performance for people who are utilizing hard disk drives in their NAS appliance. The second most common type of socket is the SATA socket, which has remained largely unchanged for the past 2 decades. However, just because the socket itself has remained the same doesn't mean that the bus speeds have. Originally, these buses were capable of only moving about 1 gigabit per second, but now with the current iteration of SATA 3 is capable of 6 gigabits per second read-write speed. There's also serial attached storage, which has doubled the bus speed of SATA at 12 gigabits per second and is partially compatible with the SATA socket. You can install a SATA hard drive into a SAS socket. You're just limited to the SATA bus speed. However, you cannot cram a SAS drive into a SATA socket without damaging the drive, the socket, or both. This is why it is important to check the socket types available on your NAS before you start purchasing hard drives for it, or vice versa. Additionally, just because you have a SAS bus on a NAS doesn't mean that you will be able to read and write 12 gigabits per second to your disks on that appliance. appliance. You're still going to be limited by your slowest bus speed, which in most cases for a NAS is going to be the network interface itself. If your NAS only has a gigabit Ethernet NIC, you're not going to be reading and writing 12 gigabits per second, you're going to be reading and writing 1 gigabit per second. And just to remind you, storage capacity is measured in bytes, speeds are measured in bits, so you're only going to be able to access 125 megabytes per second when you are working with a NAS using a 1 gig NIC. The last storage method available is a SAN, which does not stand for Storage Attached Network, which would be a hilarious mirror to Network Attached Storage. SAN stands for Storage Area Network, which does not mean that this is equivalent to a wide area network or local area network where they're based off of their geographic size. A storage area network is basically just a network where all of the devices within that network are NAS appliances, and all of these have been configured to be one giant ethereal amalgamation of data and information just waiting to be accessed. SANs require rather large amounts of bandwidth and very low levels of latency in order to be viable, which is one of the reasons why these are typically not used by anything other than large corporations, other than as a proof of concept for people going through school and getting certification exams. SANs are a fairly simple concept to understand, but they can get really complicated really quickly. So we'll go ahead and draw the line here as far as this discussion is concerned, and if people really want to go more in depth into what a SAN is and how they work, then you can go ahead and bug me in the comments below, and if you harass me just enough, I'll probably make a video about it eventually. Okay, let's stop beating around the bush and start talking about RAID strategies for a minute. NAS are typically configured in one of two ways. They are either configured as a JBOD, or just a bunch of disks, which works exactly the same way as if you just crammed a desktop or a server blade full of hard drives and created one giant storage volume from all of those extra hard drives. If any one of those drives fails, either from mechanical failure, due to too many read writes, or just good old-fashioned manufacturing defects, then all of the data is gone. You're kind of SOL unless you send your information to some sort of data rescue service that has clean room facilities, and even then, it's not a guarantee. The costs of these types of facilities are rather high, which is why a vast majority of people just end up accepting the fact that that irreplaceable data is now gone and they now get to start working from scratch to rebuild it. That's why if you're running a NAS and you are not a less than intelligent person, you're probably going to want to configure some sort of RAID strategy for your drives in that NAS. RAID, or a redundant array of independent disks, is a strategy for trying to spread your information across multiple disks in a way that allows for redundancy, so that if any one of those drives fails, you can still rebuild your data and you don't actually lose anything. There are several different types of RAID, and I could spend quite a bit of time going into detail into exactly what those RAIDs are and how they work. However, in my DRP versus BCP, which is King video, I already did that, so I'm going to let past me take care of that.
The first type of RAID is called a RAID 0, and this is normally referred to as drive striping. In order to accomplish a RAID 0, you require a minimum of 2 disks. Your data is literally striped 1 bit at a time across both drives, so that your data is not all being stored on one drive. This makes your data acquisition extremely fast because you're able to simultaneously pull information from 2 drives at once. However, drive striping doesn't actually give you any kind of redundancy in your data, because if one of your drives fails, all of the bits on the other drive are completely useless because there's nothing to cross-reference and nothing to fill in the blanks. RAID 0 is almost never used by organizations and data centers in order to store your data. It's kind of a stupid strategy, really. RAID 1 is called drive mirroring, and this is where you keep a direct drive-for-drive copy. Every single bit of data on this drive is going to automatically be copied over to a second drive. So just like RAID 0, it's going to require a minimum of 2 drives. However, this provides you with full data redundancy, so that if either your primary or secondary drive fails, then you can simply pull out your failed drive, put another one in, and never have to worry about your data being lost. RAID 5 is the most common found in data centers and requires a minimum of 3 disks. In a 3-disk RAID 5 array, your storage capacity is limited to about 2/3 of the actual hard drive capacity. All of your data is stored on that 2/3 of the hard drive, but half of that data is sent to the second disk of the array, and the other half of your data is sent to the third disk in the array. Likewise, your other 2 drives follow the exact same principle, where they have 2/3 to store their own data, and then half of it goes to the other 2 drives in the array. This is an awesome RAID strategy because it is hot swappable, meaning that without having to pull the device down out of operation, replace a drive, and then power it back up in order to re-image your drives, you can simply snap out the failed drive while the storage array is in full operation, snap your new one in, and the other 2 disks will automatically be able to populate it with the missing data. This hot swappable RAID strategy is the most cost effective while still providing full data redundancy and hot swappability, which is why data centers tend to prefer RAID 5. In addition, there's also RAID 1.0, not RAID 10. A RAID 1.0 is where you're simply combining the concepts of RAID 1 and RAID 0. In this strategy, you're going to require at least 4 disks to make it work, and this is quite simply a striped drive where you have the RAID 0 on 2 of your disks, and then you have a complete mirror of that striped drive. This is going to give you the best performance because you're going to have the benefit of that drive striping, but it's also going to actually provide you with full data redundancy. However, you're only going to have half the storage capacity of the number of drives in your array. So it's not the most cost effective. You'll usually see RAID 1.0 with high-end gamers who can afford that sort of arrangement, but you're almost never going to see RAID 1.0 in a data center application. The next is RAID 1.5, and while I've never actually seen this in practice or even seen it in textbooks most of the time, this is something that is theoretically possible, and it's basically the same concept as your RAID 1 plus your RAID 5. So you're taking your RAID 5 array and then you're completely mirroring it. So no matter what happens, you're going to have absolute redundancy. So one of the major problems with a RAID 5 array is that if you have 3 disks in your RAID 5 array, if one of your disks fails, you can always rebuild your data. But if 2 of your disks fail at the same time, that entire array has now been lost. Your RAID 1.5 means that even if 2 of your disks happen to have a freak accident and fail at the same time, you still have your mirrored RAID 5 array, which will be able to replenish your data. This is the least cost effective of all methods. And like I said, I've never seen this in application, but it gives you absolute control over your data and absolute assurance that it will never fail. I mean, as close as you can get with absolute assurances when it comes to technology.
Only a Sith deals in absolutes.
Thanks, slightly better groomed version of me who's not currently recovering from a cold. There's one thing that I didn't mention in that video because at the time of recording, I actually had never heard of this before. Now, this is not a true form of RAID, however, Synology, the vendor that we're going to be looking at a little later in this video when we're doing a demo of setting up a NAS from scratch, actually has their own form of redundancy, which they call Synology Hybrid RAID. SHR only requires 2 drives to function, while SHR requires 3 drives to function. Both use striping with parity in order to accomplish that redundancy so that if any one drive fails, then you can easily rebuild it from scratch. While RAID 5 will restrict you to whatever the lowest capacity hard drive in your array is, SHR simply removes the highest capacity drive. So if you're careful and do a little bit of strategic planning, there may be benefits for using one over the other. Sometimes a RAID 5 will give you higher storage capacity, other times an SHR will give you higher capacity. It really depends on the number and combination of drives you use. I don't quite understand the math behind how SHR works, however, they assure their customers that it is a fully redundant system that is capable of completely tolerating the loss of a single drive, just like RAID 5, so I'll take their word for it. Both of these strategies will result in a similar loss of speed, but again, unless you were a cheapskate who went with like a 5400 RPM hard drive, then you're not going to actually notice this decrease in read and write speed because your network interface is going to be your main bottleneck anyway. Okay, so that's it for the theory. Let's go ahead and move on to practical application. So full disclosure, I had to completely rewrite this section of the script. I had looked everywhere on my computer to find the footage that I had collected while I was setting up my NAS, and I couldn't find it anywhere. So I was prepared to do a rather train wreckish demo by basically just stealing online tutorials from Synology. However, I did actually find my footage. It was on the NAS. So now you actually get to enjoy the benefit of an actual demo and how to set up instead of me just explaining what Synology already publishes. Also, Synology is not sponsoring this video. I did all of this on my own, purchased it for my own purposes, so If you do want to support the channel, a like would be a huge help. Now on to the setup. I recently purchased a Synology NAS because I needed more storage for the YouTube-ins, and I didn't want to deal with the unearthly slow speed and costs of pulling from the cloud every time I needed to edit a video. For my purposes, I went with a 4-bay DS923 NAS from Synology. Typically, when you purchase a NAS, you purchase the appliance and storage drives separately, so keep in mind those drive costs will stack up pretty fast and can very quickly outpace the cost of the appliance. Start by removing all of the drive carriages that you intend to use. These can be locked or left unlocked for tool-free removal and install. There are 2 additional removable panels on the underside of this model for M2 4-factor drives, which can be added for SSD caching. Initially, I did not purchase any M2s for this setup, but I did eventually purchase a 2TB SSD and add it for caching purposes. Next, you will want to mount your drives in the drive carriages. With Synology, this is a tool-free process for 3.5-inch form factor drives. However, with smaller drives or other vendors, you may need a screwdriver to mount your drives. Next, you will want to install your drives, beginning with bay number 1. In this example, bay 4 is unused, which is why I installed it first. Make sure that your drives are completely seated, but do not force them. No additional force was necessary to see any of the drives I used. Gravity alone was sufficient to mount them. Connect the necessary power adapter and RJ45 Ethernet patch cable. You can connect the NAS to your switch or directly to your router for network-wide access, or if you only need a single device to have access, you can connect directly to your computer's Ethernet port for reduced latency. Finally, power on your NAS and wait for the device to boot by ensuring the power indicator is solidly lit and all drive indicators are lit for the applicable drive bays. There are 2 different methods of setup. The first that Synology prefers you to use is to download the Synology Assistant by going to finds.synology.com and use the auto-locate feature in the Assistant software to locate your NAS. Unfortunately, it couldn't detect my NAS, but that's okay, there's a second option. If the assistant is not working for you, you can simply open a web browser and navigate to Synology NAS :5000. This will attempt to connect to any device on your network with that default hostname over port 5000. From here, the setup is pretty much the same. You're just doing it via Web Management Console instead of the Synology Assistant software. First, you'll need to download the latest version of the Synology operating system, DSM. Next, you'll be prompted to set a hostname and create an administrator account. At this stage, you will be able to decide whether updates will be collected and installed automatically or whether to notify you when an update is available. The second option may be preferred for businesses where high availability during work hours or change windows are a direct concern. You will also be prompted to set up a Synology account, but you can skip that step for now. Next, you'll be prompted to create a storage pool and volume. A storage pool is the collection of disks that you want to be grouped together for equal treatment. For most implementations, you'll want a single pool including all disks, but you could create different pools using separate disks using different RAID types if you wanted. The first step is to select the RAID that you wish to use and provides a basic description of the requirements and level of fault tolerance that is offered by that specific form of RAID. The options available are based on how many drives are currently detected in the NAS. Next, you will have to choose which drives you want to participate in this storage pool. For this demo, I chose all drives. Synology will check drive compatibility just to make sure that the drives you're using are from a reputable vendor. The Seagate Ironwolf drives that I used were considered incompatible, but don't worry, the process should still work regardless. Next, you'll want to set how much of the available storage on these drives you want to use for the storage volume, which in most cases will be all available space. Next, you can select the file system, either the BTRFS file system or ext4, which mostly serves as a backwards compatible option when migrating from older Synology NAS or from Linux file servers. Finally, you are brought to the Storage Manager dashboard, which shows the health of the installed drives and information regarding storage pools and volumes. However, this does not mean that the NAS is ready to interact with your network just yet. From here, you'll want to move over to the Files station, which will prompt you to create a shared folder which will allow data to be shared outside of your NAS appliance. This is fairly straightforward. Just click OK, give it a name, select the volume it should be located on, and continue onward. There are a number of privacy and user-based restriction options, but for this demo, we will leave all of these settings in their default options and complete the wizard. Lastly, this isn't completely necessary, but is highly recommended, especially in a business environment, that you set a static IP address on your network interface cards. Head over to Network, select the LAN port you're using to exchange data, and click Edit. This will allow you to set IPv4 and IPv6 information on your NIC. From this point onward, you have a fully functional NAS connected to your network and ready to provide storage to your users. There are a pretty large number of additional configurations you can do to control access, to allow for centralized authentication, etc., but these are just the basics that will apply to all users. To access your new share via a Windows workstation, open the File Explorer and, if necessary, navigate to this PC. Click the ellipses at the top and select Map Networked Drive. Select a custom drive letter if you wish, and type the hostname you provided for your NAS earlier in the configuration, preceded by double backslashes, and click Browse. You will be prompted for the admin account for your NAS and will provide a list of all publicly visible shared folders on the NAS. Select the one you want to map and click OK, followed by Finish. Now you can interact with the folder the same as you would any other Windows storage volume. And that's pretty much it. That's everything you really need to know about network attached storage, as well as a quick demo on how to set up a Synology NAS. Are there any considerations before you purchase a NAS that we forgot to mention? Are there any configurations we left out of our demo that you think should apply to all users? Definitely let us know in the comments below. As always, a like would be extremely appreciated if you found this video valuable. And until next time, this has been Brain Melt University, and we hope to see you here next time. Stay safe.